Assalamu alaikum. This is Zafar Ali Khan and I'm here with the Logic Gate lecture 7. This lecture is about, this 7th lecture is about past paper questions, and in particular those questions which look different and feel different than what we have been doing over last 6 lectures. So to cover it 360, it is necessary to look into past papers and see if there is anything different than what we have understood. We should cover it up as well. So let's see. Look at this particular question. We have got two outputs in it, E and F. तो अभी तक तो हमने जितने भी सर्किट्स देखे थे उसमें एक आउटपुट थी, इसके अंदर दो आउटपुट्स हैं, तो इससे कोई फर्क नहीं पड़ता. ये E जो है हम इसको इस तरह लिखेंगे कि E इज इक्वल टू A प्लस बी होल नॉट एंड F इज इक्वल टू A प्लस बी होल नॉट प्लस B होल नॉट. Okay, so this is not anything which is different, but yes, अगर आपके पास कोई ऐसा सर्किट हो जिसकी दो आउटपुट्स हैं और उनका नाम जो है वो S और C हो, तो S इज फॉर सम एंड C इज फॉर कैरी, तो ऐसे सर्किट को हम कहते हैं एडर्स. इन सर्किट्स का काम जो है वो दो वैल्यूज को ऐड करना है. ये हमारे प्रोसेसर के ALU के अंदर होते हैं. ALU का मतलब ये है कि अर्थमेटिक लॉजिक यूनिट, और ये दे आर यूज्ड टू ऐड टू डिफरेंट वैल्यूज, सो दे आर एडर्स. सो अब आप देख सकते हैं 0 प्लस 0 अगर हम बाइनरी में ऐड कर रहे हैं तो 0 बनता है. इसी तरीके से 0 प्लस 1 अगर हम ऐड कर रहे हैं तो 1 बनता है. 1 प्लस 0 जो है वो 1 बनता है. 1 प्लस 1 बाइनरी में 2 बनता है, ये 2 बिट की बाइनरी है. और इसी तरीके से 1 प्लस 1 जो है वो 3 बनता है. तो अब आप देखें ये जो राइट वाला बिट है इसको हम सम बोलते हैं, लेफ्ट वाला जो है वो कैरी होता है. ये सम है, ये कैरी है. तो यहाँ पे तो सिर्फ सम है तो कैरी हम खुद 0 लगा देंगे. ये भी सम है तो हम कैरी 0 लगा देंगे. ये भी सम है तो हम कैरी खुद 0 लगा देंगे. So this is how these circuits work. At the moment they are not basically the concern. Just to tell you, आप इसको आराम से सॉल्व कर सकते हैं, because W is equal to A plus B यहाँ के ऊपर, यहाँ पे जो है X is equal to A and B whole not, और इन दोनों को एंड करेंगे तो आपको सम मिल जाएगा, ए एंड बी करेंगे तो आपको कैरी मिल जाएगा. तो बाय सेइंग दैट आपका कोई इशू नहीं है. लेकिन कहाँ पे प्रॉब्लम होती है, जब इसका पार्ट बी आता है, स्टेट अ पॉसिबल यूज फॉर दिस सर्किट इन अ प्रोसेसर. तो अब आपको यहाँ पे बताना होगा कि दिस इज बेसिकली एन एडर विच एग्जिस्ट इन ALU एंड इट इज बेसिकली यूज टू ऐड टू डिफरेंट बिट्स. ऑलराइट, सो व्हाटएवर दैट आई हैव सेड इज नॉट द कंसर्न फॉर यू, only to let you know that if a circuit has got two outputs, and specifically if the name of those two outputs is sum and carry, it means that this is a special type of circuit called adders, which when two values are given as in A and B, they actually add this up and gives you the output. Over here आप इसको जो है वो यहीं से, जैसे W को हमने किया A plus B और X को हमने किया A and B whole not, तो आप उसको देख सकते हैं. और C क्या है, बेसिकली जो C है वो है A एंड B. आप इसको आराम से सॉल्व कर सकते हैं, ठीक है ना. और सम को आप कैसे देखेंगे, सम को आप देखेंगे W एंड X, तो ये आपका आंसर आराम से निकल आएगा. यू वुड हैव नो इशू विद इट, बट नोइंग व्हाट दीज गेट्स आर विल हेल्प यू टू सॉल्व सच क्वेश्चंस. ओके, आगे देखते हैं इफ देयर इज एनी. सो यहाँ पर भी ये E एंड F है तो नो इश्यूज. वी आर लुकिंग इनटू क्वेश्चंस बट दोज क्वेश्चंस व्हिच सीम्स डिफरेंट. अच्छा, अब आप देखें इस पर्टिकुलर सर्किट में आपके पास 3 इनपुट्स हैं. तो 3 इनपुट्स का मतलब हुआ कि आपके लॉजिक ट्रुथ टेबल पर आपके पास 8 पॉसिबिलिटीज होंगी, 0 to 7. तो अब जब हम इसका ट्रुथ टेबल देखते हैं तो इन्होंने जो पॉसिबिलिटीज यहाँ पे प्लेस की हुई हैं वो सिर्फ 4 है. इट मीन्स दैट इट इज इनकम्प्लीट. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So we would have to actually complete it by making it 4, 5, 6 and 7. Now, if you see a logic truth table and it is basically made up of 3 inputs and half of them are gone, you would have to fill it yourself. I still remember the year it appeared. It was basically 2012. A student got back to me and said that, sir, we haven't completed it because all of the questions we ever had were having all the possibilities already given, so we thought that we don't have to actually complete it, so we only worked for the possibilities given and we left out all the rest of it. So be careful about it. If you have got 3 inputs, definitely you would have 8 possibilities, and if those 8 possibilities are not there, whether partially or fully, you would have to complete it yourself. So this question says that draw a logic circuit corresponding to the following statement. So A and B, or B is 1 or C is not 1. So this is your logic circuit that you can easily make A and B or C not, and R. So this is X. Okay. All right. Now they ask you to complete the truth table, so you will be completing truth table over here. Such questions are they're general and they always appear, so be very much careful about it. Practice them well. Now look at this question. A combination of three lights is to be shown in a set sequence at a rock music concert. Rock music concert. The three lights are red, green, and yellow. The sequence is as follow. Red only for 3 seconds, red and green for 1 second, yellow only for 3 seconds, green only for 1 second. A counter is used which consists of 3 bits A, B, and C. The counter is incremented every second and recycled continually. A logic circuit is to be built to generate the sequence of lights. A Boolean value of 1 represents the light switched on. The lightning sequence starts with red only. Complete the truth table for the sequence of lights. All right. Now, what did you get? Nothing that I know. अगर आपके पास कोई ऐसी सिचुएशन हो कि आपने पूरा सवाल पढ़ा है, you don't get anything out of it, doesn't matter. Carry on. Next part will help you to understand what it is. अब आप जब next part देखेंगे, तो here you can see R is equal to 1 if A is not 1. So it means that R is equal to A naught. So get back. R is equal to A naught. So A naught means 1, 1, 1, 1, 0, 0, 0, 0. There we go. We have started solving it. G is equal to B is 1 and C is 1. So B and C. So G is basically B and C. 0, 0, 0, 1, 0, 0, 0, 1. Then Y is equal to 1 if A is 1 and not B and C. So B and C whole not. Alright. So you have B and C already made. So B and C not will be G naught. So 1, 1, 1, 0, 1, 1, 1, 0. Now B and C whole not and A. This is your Y. So this one and this one. 0, 0. So this is A G naught. 0, 0, 1, 1, 1, 0. So you have it. You solved it already. So get the idea. So whenever you come across a situation which you don't get at all, so what you have to do, instead of wasting time, just move on. Chances are the next part will help you to solve the previous one. Now you can see, if you take this one, R is equal to A naught. So A naught goes to R. A naught goes to R. Okay, A naught goes to R. G is equal to B and C. So there we go, B and C. B and C goes to what? G. And Y is equal to B and C whole naught and A. So there we go, B and C whole naught. It means that we already have B and C. हम इसको not करके इधर ले जाएंगे. And then A. So A. And this goes to Y. So very simple, the whole question is solved. R is equal to A naught, R is equal to A naught. G is equal to B and C, so this is G. Y is equal to A, okay, A. And B and C not. So B and C we have already made it, so not इसमें चला गया. So this is V on Y. So you see, you have actually done it properly. Let's see if we have got other questions which are different. All right. अब आप देखें यहाँ पे एक question है. 4 sensors हैं. Sensor 1, sensor 2, sensor 3, sensor 4. Sensor 1 and 2 की जो output है वो A है. So A is equal to sensor 1 plus sensor 2. B is equal to sensor 2 and sensor 3. C is equal to sensor 3 or sensor 4. Alright. तो अब अगर आपसे यहाँ पे ये पूछता है, since there are 4 outputs, 4 outputs का मतलब, sorry, 4 inputs, तो 4 inputs का मतलब हो गया 16 possibilities, 0 to 15. So you would have a larger truth table, but actually it is very simple. So A is sensor 1 plus sensor 2. So this is plus means OR gate. So 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Alright. B is equal to S2 and S3. So 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. So you see, it really does not matter how big is the truth table. If you have everything in control, you will actually be doing it easily. All right, let's move on. You see, although you have got 16 possibilities and a larger truth table, yet the marks are same. Okay, so keep that in mind. Over here, they say there are three parts of the chemical process being monitored. Each part is monitored by its own logic circuit. A fourth logic circuit a fourth logic circuit has X, Y, and Z as input. So the output of this logic circuit is X. The output of logic circuit 2 is Y. The output of logic circuit 3 is Z. So you don't have to worry about it. You will still see that this logic circuit has three inputs, X, Y, and Z, and output is W. So they say that W has a value of 1 if X is 1 or Y is 1. So X or Y is 1 and Z is equal to 0. And I told you that whenever we have got 0, we are actually making use of NOT gate. So this is very simple. Now you can make it X or Y, and then we have Y and Z naught. They both are being odd, or W is the output. Okay, a student in an electronics lesson build the following logic circuit. Complete the truth table for this. So आपको इसके लिए क्या जो इक्वेशन बनानी पड़ेगी वो क्या बनेगी? यहाँ पे बनेगा A B naught. यहाँ पे क्या बनेगा? A and B. यहाँ पे क्या बनेगा? A and B again. और यहाँ पे क्या बनेगा? A and B and C. यहाँ पे क्या बनेगा? A B और A and B and C. और यहाँ पे क्या बनेगा? यहाँ पे आएगा A B naught और A and B और A B and C. All right. So this is a large lengthy equation. तो अब आप इसमें क्या, पहले आपको B का नॉट चाहिए, आप B नॉट सॉल्व करेंगे, फिर आपको A B नॉट बनाना होगा, फिर आप जो है वो A B क्रिएट करेंगे, फिर आप A B इंटू C क्रिएट करेंगे और फिर आप जो है इस पूरे को सॉल्व करेंगे. यहाँ पे लेट से आप इसको M बोलते हैं, फिर आप M के लिए सॉल्व करेंगे, फिर M और A B नॉट, इन दोनों का जब और होगा तो दैट विल बिकम योर X. ओके, इसमें अब आप देखें X हैज़ द वैल्यू 1 इफ साउंड लेवल इज ग्रेटर देन 90 डेसिबल्स. अब आप देखें ग्रेटर देन 90 डेसिबल्स इज बेसिकली S is equal to 1. So this is S, and temperature is greater than 35. So and temperature is greater than 35 means T is equal to 1. So this is S and T. S and T. Now this one or यहाँ पे आपके पास और आ गया. Temperature is greater than or equal to 35. We know that it is T. And oxygen level is less than 75. So oxygen level less than 75, it is G naught. T G naught. All right. Now this is OR. So we have got another OR. Sound level is less than 90 decibels. Sound level less than 90 decibel means that we have S naught. S naught. And oxygen is greater than 75. Oxygen is greater than 75 is G. Alright, so S naught G. और अब हम इसमें ब्रैकेट्स लगा के इसको कंप्लीट कर लेंगे. Okay, so S and T, T G naught, T G naught, इन दोनों का हमारे पास हो रहा है और and then we have S naught G. So S naught G और इन दोनों का आपस में क्या हो रहा है और. So we have got now 1 2 3 4 5 6 7 gates. It's lengthy one, so you have more marks for it. Okay, so you have got more marks for it. 7 gates. So it's a bigger logic network. Write the logic statement of this circuit. So this one is not A, this one is AND, this one is B. Logic what? Logic statement. This one is B not, so not B. This one is OR, this one is C. Okay, so these two are being ORed, so we have an OR over here, another bracket. then this one is AND, this one is AND, and this one is C naught, not C. So how do we write the whole equation now? X is equal to 1 if, that is what your logic statement for this particular circuit. Okay, now last question. If you see, we have got 1, 2, 3, 4, 5 inputs. Okay, 5 inputs. So A is a switch, A is a switch, B is a remote control, C is infrared sensor, D is infrared sensor, E is door pressure. Now let's interpret this question. An alarm system X is enabled and disabled using either switch A or remote B. So this is very simple. X is equal to A or B, which says that an alarm system is enabled and disabled using either switch A or remote control B. Is enabled and disabled. Okay. There are two infrared sensors C and D and one door pressure sensor E. Now let's solve it. An alarm sounds X is equal to 1. X is equal to 1. If alarm is enabled, how it gets enabled? Whenever we have A or B, it is enabled. We have just read it over here. An alarm X is enabled or disabled using either A or a remote control B. So, alright, either of them is 1. So the whole thing is up. Alarm is enabled and this is AND. Any one or more of the sensors is activated. Alright, so how many sensors do we have? C, D and E. So it means that we can write C or D or E. C or D or E. Okay, so there we go, that's it. Alright, so the alarm sound X is equal to 1 if the alarm is enabled. How do we enable the alarm? By having either switch A or B. So A or B. And any one or more of the sensor is activated, means C or D or E. Either of them is 1, the whole answer is 1. Draw logic circuit. So how would you come up with it? A plus B. So A or B. C or D. C or D or E, and we have got what? AND gate. So if you could interpret it, it is easy. If the circuit is enabled, which means that any of these two are 1, then it is enabled, and either or all of these or any of these 3 C, D and E are up. So it means that if there is 1 over here or here or here or in any combination, the result will be 1. So it is 1, it is 1, the alarm goes off. So my viewers, my students, my lovely audience, this is it for the logic gates. We have covered all sort of questions that we could, and I hope that this will help you to learn logic gates. Anything that you don't get, rewind the video or stop the video, take notes, rewatch them, whatever that you could, and try to make yourself comfortable with this topic. I understand that this topic is not as comfortable as it seems. It requires a lot of practice, but practice makes every man perfect. So that's it with logic gates. I'll see you with another topic in another video. Thank you.